Right, just to make this clear, this is the difficult question we did in class. So I've got a recurrence sequence, un, okay, and they give me my first term, which is u1, and that is k. Okay, so now it gives me two different definitions. It gives me one for 2n and one for 2n plus 1. And we know that 2n is an even number and 2n plus 1 is an odd number. So what that means is if I pick n equal to 1, then u of 2n is u2, and u of 2n plus 1 is u of 3. Same thing, if I pick n equals to 2, that means u of 2n equals u4, and u of 2n plus 1 equals u5. Okay, so what I'm going to end up with, I'm going to end up with two separate sequences. I'm going to end up with an even sequence and an odd sequence. My even sequence is going to be u2, u4, and u6. My odd is going to be u1, u3, and u5. Okay, so let's work out what those terms are. So if u1 is k, then u2, by our definition, is 2n minus 1. Well, if 2n is 2, then 2n minus 1 is u1. So that's u1 times p. And u1 was k, so that's k times p. u3 is an odd term. Well, sorry, let's do u1. So u1 is k. Okay. u2 was kp. u3, this is an odd term, means that is u2n, the even term. And remember, if 2n plus 1 is 3, then 2n is 2. So I've got u2 times q. And u2, as we just wrote at the top, is kp. So this would be kpq. And then we have u4. Remember, u4 would be the term before u3 times p. Well, that was kpq, so this is kp squared q. u5 is going to be u4 times q, so that is kp squared q squared, and u6 is going to be u5 times p, which is kp cubed times q squared. Right. Okay, so now we can see we're multiplying, so these are geometrics. So we need A and we need R for both. So from our even sequence, our first term was u2, and that was kp. R, we're multiplying by p each time. So we've got kp, next term is kp squared q, so we're actually multiplying by pq. For the odds, our first term is k, and you can see the next term is kpq, and then kp squared q squared. So again, we're multiplying by pq. Now, we've got our first 6 terms. Now we need to show that the sum is equal to this formula. Well, as it's a sum, because it's sigma, we know what the sum of a geometric series is. The sum of a geometric series to infinity, to n, because we're doing 2n. Now remember, basically half of it is even, half is odd. So I'm going to do a sum to n for even and sum to n for odd, and then I'll have 2n terms. Right, so For the evens, it's a times 1 minus r to the n over 1 minus r. Now our a was kp times 1 minus r, which is pq to the power of n over 1 minus r, which is pq. And then for the odds, again, it's a, which is k, times 1 minus r, pq to the power of n over 1 minus r, which is pq. Right. Now to get two n terms, I have to do n plus n. So I'm going to add those two sums together to get the total. So I'm going to do kp times 1 minus pq to the n over 1 minus pq, and I'm going to add to that my k times 1 minus pq to the n over 1 minus pq. Well, we can see that we've got a common denominator. So that means basically that we can turn it into a single fraction, 1 minus pq, and that means I'm going to have kp times 1 minus pq to the n plus k times 1 minus pq to the n. And again, as both of them are multiplying the same thing, I can then factorize this. So this is just the tidying up part at the end of the question. So that means that I've got kp plus k times 1 minus pq to the n, all divided by 1 minus pq. And again, I've got k is a common factor for both of these terms. So I'm just going to write this as k times 1 plus p times 1 minus pq to the n, all divided by 1 minus pq. And that is exactly what the question was looking for. So that is my final answer.
How are you?